All right, geometers, the last time we were together here, just making a video or watching the video, we were on number 2 of an Inscribed Angles worksheet that if you were my student, you might have been working on. So I'm going to pick up on number 3. So let's look at this. Now that 49, it almost seems a little ambiguous what it's talking about, but it pretty much could only be referring to the angle that has one side TR and the other side TK. So let's go ahead and assume that the 49 degrees is referring to that angle. Well, if the angle is 49 degrees, then the arc intercepted by that angle, because that's an inscribed angle, its vertex is on the circle. And guys, be aware that that becomes very important, especially in the section we're about to talk about. Next, after inscribed angles, we're going to get into dealing with angles that are formed by secants and tangents, where the vertex might be outside the circle, or it might be on the circle, or it might be inside of the circle. And that's a key thing, is knowing where your vertex is. In inscribed angles, vertex is always inside the circle, and the angle is always half the arc. So if that's 49, then the angle that it intercepts has a measure, the arc it intercepts has a measure of 98 degrees. Well, the reason that's significant is because over here we have, well, TR, whoa, a little crazy there. TR is a diameter in this circle. So that means everything on this side of it is 180. Keep your eye out for diameters in these problems. Anytime you see a dot right in the middle, that's implying that's the center of the circle, and any chord that goes through it is a diameter. So everything on one side of it is 180. So everything over here is 180. So if I already know this portion here is 98, all I have to do to find the question mark is to subtract that 98 from 180. Next, we have a quadrilateral inscribed in a circle. And we have a rule about that. Remember, we have a special property that says that a quadrilateral can only be inscribed in a circle if opposite angles, meaning the ones across from each other diagonally, like D and F or E and V, opposite angles have to be supplementary. So what that tells me is if this is 96, then the angle across from it, diagonally across from it, or opposite it, has to be supplementary to that. So it has to be 180 minus 96, which is 84. So this angle is 84 degrees. Okay, well, that angle looks like this. It has its vertex at F, which is on the circle, so it's an inscribed angle. One side goes out here, and one side goes out here. And I'm going to pause for a second. Okay, so back to my blue angle. It measures 84 degrees. It's an inscribed angle, so that means that the arc it intercepts, which in this case goes from V around to E, has to measure twice as much as 84. The angle is half the arc. Well, twice as much as 84 is 168. So everything from here around to here is 168. Well, we already know this part of that is 78. So if we want to know the part that has the question mark, we're going to have to subtract 78 from 168 and get our answer. All right, next, first thing I need to notice about this picture is that it has a diameter. That's a really key thing to start recognizing, is that we have a diameter, which means everything on one side or the other side has to add up to 180. Okay, so this particular diameter is one of the sides of my angle. So I'm going to say I've got an angle ZY is one side and ZX is the other side. So my angle is YZX or XZY. Its vertex is Z, which is on the circle, so it's an inscribed angle. So inscribed angles always have a measure of half the intercepted arc. Well, we don't know the intercepted arc or the inscribed angle, but remember, we do know that this is a diameter, and that means that everything on one side of the circle has to add up to 180. And we already know that this portion is 108. So if I subtract 108 from 180, I get 72 degrees. And this arc XY, is 72 degrees, which means that the angle in question is half of that. Inscribed angles are half the arc they intercept. So half of 72, which is, what, 36? Next, another quadrilateral in a circle. Remember that opposite angles have to be supplementary, but guess what? On this one, we don't really need to know that, because if we look at the angle we were given, angle V with sides VA and VC, it intercepts this arc, the arc that goes from A to C. And what we need to know is part of that arc. So if I know that the angle is 74, that means the arc is going to be twice that. And twice 74 is 148. Did we just do the same problem? It seems very familiar. Maybe not exactly the same, but very similar. Could be exactly the same. So we have 148 is from here around to here. It's not the same. And this portion of that is 82. So if I subtract 82 from 148, I will know how big arc AB is. Next, we have angle YWX or XWY. That's not a good side. Let's try and do a little better here. There's my angle. The angle is an inscribed angle because W is on the circle and that's the vertex. So inscribed angle is half the measure of the arc it intercepts. Well, here's the arc it intercepts. 39 is half of what? Well, multiply 2 times 39, you get 78. Not sure why it says here, but you get 78 degrees, and that is arc XY. Okay? Well, the part of the circle that we want to find, and this is a classic case, by the way, you notice that up until now I haven't even dealt with the fact that the question mark's over here. I just looked at what I was given and thought, what does this tell me? Okay, so always keep that in mind. If you don't necessarily know the answer to the part of the question you're being asked, or how do I get this answer, see what you know in terms of what you can find. Like, what do I know? What could I start with? What could I find out based on what I have now? And that's exactly what I did. I said, if this is 39, this is going to be 78, even if I didn't know how that was going to help me. Well, now I know how it's going to help me, because the question mark portion of the circle, the question mark arc, is the only part of the circle that I don't know. I know that this part is 78, and I know that this part is 150. So if I take the two parts that are 78 and 150 and I add those together, 78 plus 150 is what? 228? This orange arc here is 228 degrees. If I subtract that from 360, I'll know how big the arc WY is. And here we go. We've got another quadrilateral inscribed in a circle, a lot of these. And on this one, again, it helps to know that quadrilaterals can't be inscribed in a circle unless opposite angles are supplementary, because this angle intercepts this whole big arc that I'm working with here. Okay, so if I knew this whole red arc, then I could find this arc right here, CD, by subtracting 60. So it's going to help me to know this whole red arc, or to know this red angle, which I can do because it's opposite in an inscribed quadrilateral from 102, which means this angle and 102 together have to add up to 180, so the angle is 78 degrees. So this is 78, because 78 plus 102 makes 180. 78, the angle, is half the inscribed arc, so 78 times 2 is 156. Does that seem reasonable? I believe it does. Probably should have a calculator. But 156 is, let's see, this whole part all the way around. So if we know that this portion over here is 60, 156 minus 60 will give me this arc right here, arc CD. All right, next one, number 9. Well, we got a few things going on here. So I'm just going to look at it from the standpoint of what could I find? Well, I have an inscribed angle here. I have angle F, which is 85 degrees. Okay, it intercepts, excuse me, arc RQP. So 85, the magenta angle, if you will, has to be half of the blue arc. So the blue arc is going to be 2 times 85, which is 170. Okay, so this whole blue arc is 170. Well, this portion of the blue arc is 62 from Q to P. So that means 170 minus 62 is going to give me, the other portion of the arc. So that's 108. So that's from R to Q. All right, now, this one I had to do a couple of things. I had to find those before I can go find the other ones. So now I'm going to make this, let's see, make my eraser smaller. I'm going to come over here and I'm going to focus on a different angle. I'm going to focus on angle. You may or may not be hearing my son try to shush 2 kitties who are not very happy with each other. They're chasing each other through the house. Just thought I'd explain that. I also wanted to explain in his behalf, in his defense, if you were listening to my last video where I was wondering why on earth my son was continuing to make loud crumpling noises when I was commenting on it, after I finished making the video, I was like, so why were you doing that? And he said, huh? And took out his earbuds. So, yeah. Anyway, back to this problem. The purple angle intercepts the arc from Q around to F. Okay, so if I know the purple angle is 74, then I know that the arc from Q around to F is twice that, which is 148. Boy, we like 148 on this page, don't we? All right. So that's all the way around here. Now I can take the 108 that I found earlier and subtract it from 148 to tell me what this other arc is. Ooh, this one looks fun. Okay. I think it's going to be helpful here to remember that anytime you have 2 angles intercepting the same arc, remember this is one of our theorems, 2 angles that intercept the same arc, and in this case I have C, angle C, that intercepts arc RQ, and I also have angle P that intercepts arc RQ. They have to have the same measure. They have to be congruent because they're both going to be half of arc RQ. Type here. There we go. So angle P is 30. All right, now that's about all I needed with that. I'm going to get rid of this orange here. And focus on the fact that I have a triangle here. And one of the angles of my triangle is 30. Now remember, if you have a triangle inscribed in a semicircle, it has to be a right triangle. This has to be a 90-degree angle because from P to R is half a circle, or 180. So if angle Q intercepts an arc of 180 degrees, it has to be half of 180. So this has to be 90. So we have a right triangle with one acute angle that is 30, which means the other acute angle has to be that. Now that's all I've got space for on this video, but if you want to come back, I wanted to make another video just to show you a couple of problems that have algebraic arc measures instead of numerical ones.